Hi, in this video, I will be showing you problem number 19 of chapter 9 section 5. Solve the initial value problem x y prime equal to y plus 8x square sin x with the initial condition y of pi equal to 0. We have seen two types of differential equations. One is separable, the other one is linear differential equation. A linear differential equation would look like dy by dx plus p of x y equal to q of x. So we have to then we have to find out the integrating factor, which is e to the exponent integral px dx. Then the linear differential equation, the left hand side of which can be written as a perfect differential by multiplying by the integrating factor. So first we have to bring this given equation in the problem to make it look like a differential equation of the kind, linear differential equation of the kind dy by dx plus px times y equal to qx. So first, we will divide the whole thing by x. So xy prime equal to y plus 8x squared sin x. We are dividing the whole thing by x. Assuming x is positive, then we get y prime equal to y over x plus 8x sin x. In order to make it to look like this linear differential equation, we have to have the y prime and the y on the same side. So we will do that. So we will move the y over x to the left hand side. So it is now y prime minus y over x equal to 8x sin x. Now this equation now looks like y prime is p of x plus p of xy equal to q of x, where p of x is the coefficient of y, which is negative 1 over x in this case, the function in front of y. Then q of x is the right hand side function, which is 8x sin x. So this is our linear differential equation. We'll call the given original equation as 1, the modified one as 2. And we're going to find out the integrating factor, which is e to the exponent integral px dx. So which is in e to the exponent integral p of x is negative 1 over x. So negative 1 over x dx, which is e to the negative ln x, or e to the ln of x to the negative 1. E and ln are inverses of each other. So the integrating factor is x to the negative 1. In other words, it's 1 over x. So the integrating factor is 1 over x. We'll call it step 3. Now we are going to multiply both sides of equation 2 by the integrating factor 1 over x. So we get 1 over x times the left hand side of 2 equal to 1 over x times right side of 2. Now if we distribute this y prime over x minus y over x squared equal to, if you x and x cancel out on the right hand side, so it's just leaving you with the 8 sine x. The left hand side can be written as a perfect differential. The integrating factor is 1 over x, and then y, the whole thing prime, would be equal to 8 sine x. So if you check, when you differentiate this 1 over x times y, you have to get the left hand side there. So it is 1 over x times y prime plus y times derivative of 1 over x, which is negative 1 over x squared. Now we are going to integrate both sides. That is our next step. So integrate both sides. So integral of 1 over x y prime dx equal to integral of 8 times sine x. So as we have the derivative and integral are inverse processes, so we get 1 over x times y on the left hand side, which will be integral of 8 sine x, that is negative 8 cosine x plus c. If we multiply both by x, we get negative 8x cosine x plus cx. Now, we are given one more condition in this problem. It's an initial value problem. We are given y of pi equal to 0. So what this means is when x equal to pi, y equal to 0. So that might give us the value of c. We will check. So y equal to 0 minus 8 pi cosine of pi plus c times x equal to pi. So it is 0 equal to 8 pi cosine pi, which is negative 1, plus c pi. This gives us 8 pi plus c pi. Or if you cancel the pi, 8 plus c equal to 0, or c equal to negative 8. So plugging it back into the step for y, we get the solution to the problem is y equal to negative 8x cosine x plus cx, but cx is negative. So we get y equal to, going back to the step, negative 8x cosine x plus cx, but c equal to negative 8, so negative 8x. So the solution is y equal to negative 8x cosine x minus 8x. So anytime you have an initial condition, or which is called an initial value problem, it will be possible for us to find the constant that is present in the problem. Hope this video helps.